math people come up with these formulas?
Yes.
Yes.
I mean, maybe you haven't really thought about it deeply, but you probably kind of ask yourself that. How do they even come up with these stupid formulas? And then they just say, all right, do this formula. Well, really, we actually get a formula from thinking about what we're doing. So let me show you what we're going to do. I'm going to take this, and you want to write this down because this is one of the questions on the test. And it just says, show how to derive the quadratic formula. So I'm literally going to show you how math people figured out the quadratic formula. Okay? Just like, what are some of the other famous formulas? Just like area of a circle, pi r squared. There's a way they actually figured that out, right? Pythagorean theorem, there's ways they figured that out. So some of these cool formulas and stuff, we just figured out. So I'm going to show you. Okay? I'm going to solve this equation for x. Meaning I'm going to get x by its what? Self. The problem is, can I get x by itself the way it's written? No, there's two x's. Everybody see that? But I'm going to solve this for x in terms of a, b, and c. What are a, b, and c representing when I usually see an equation? The a represents the quadratic coefficient, the number in front of the square. The b represents the number in front of the x, or the linear coefficient. And the c represents the constant. So you might want to write this in your notes just so you know what we're talking about. That is the quadratic coefficient. This is the what? Linear coefficient. And this is the constant. Okay? And we're going to do this by completing the square. We're going to solve this for x by completing this square. Everybody ready? What's the first step in completing the square if I was solving this equation?
Subtract c.
Subtract the c to the other side. Okay? If I was using quadratic formula to solve this equation, I would get the constant. Now normally there's numbers all over here, right? But I'm going to solve it in general. How come I'm solving it in general in terms of a, b, and c? Because then, from then on, do I even have to do completing the square ever again? No, I can just use quadratic formula every time. My life will be easier. That's good. Again, math really is about trying to make your life easier all the time, which is weird. It's backwards for most stuff. Most stuff, you start out with what's easy, and then you end up with what's what? Harder. But in math, we're actually starting out, we show you the ins and outs and nuts and bolts that are difficult, and then I'll like completing the square. And then we show you, well, let's use completing the square to create a formula which makes the whole world easier, which is what I'm going to do today. So we get that by itself. Now what should I do? I can't complete the square with a coefficient on the square, on the quadratic term. How do I get rid of that a in front of the quadratic term? Divide by a. I'm going to do that. Every term. Divide by a. Everybody with me so far? Okay. I have x squared plus b over a x equals negative c over a. Now what am I going to do? Complete the square. How do I complete the square? Take the middle term. What is the middle term? B over A, and divide it by what? 2. I'm going to flip and times that. Oh, sorry, B over 2A. By the way, does that look familiar?
Yeah.
When did we use B over 2A? We actually used the opposite of B over 2A.
To
To find the vertex, right? So we've actually done part of this already, but we're going to take B over 2A, and then what are we going to do with that? Square it. This is completing the square. You take the linear coefficient, number in front of the x, take half of it, and square it. Okay, that's how we complete the square. So I have x squared plus b over ax plus b squared over 4a squared. How come I have a 4 there now? I thought it was a 2.
2 squared.
2 squared, right. 2 squared is what? 4. So I did square that out. Okay. Hey, if I add b squared over 4a squared here, what do I have to do on the other side? What do I have to do over here? If I add it to this side, what do I have to do to this side? Keep it equal. Add it to this side. So I'm going to add it. What's the problem with this? What's the problem with adding those two?
They don't have a common denominator.
They don't have a common denominator. Who said that? Very good. So Sabrina, what should I times top bottom of this one by?
4
4 what?
a squared.
4a. It already has 1a.
Oh, 4.
I need 2 of them, so I need 4a. Everybody agree? I'm going to times that by 4a, and I'm going to times the top by what? 4a. It's really my 4a. Never mind, you guys don't know what 4a is. All right, never mind. That was funny, but never mind. Minus 4ac. I'm going to write the b squared first. Is that okay with everybody? I'm going to put the square first. Because now do I have a common denominator? Yeah, so I can write this one or this one first. It doesn't matter. I can write that term first or this term first. But I'm going to put the b squared first because I want the square first. B squared minus what? 4ac. Can you see I got the 4ac? 4ac negative minus 4ac. Okay, and then I got the b squared over here. But I can put those together all over the same common denominator, which is what? 4a squared. Everybody with me so far? Okay, I've completed the square, added the square value to both sides. Okay, now I'm ready to put this side in one set of parentheses. That's why I complete the square, is to put this side in one set of parentheses. What's the one set of parentheses here? Square root of the first term, sine of the middle, square root of the last term. What's the square root of this term?
1a or 2a.
Yeah. And then the whole thing is what? Squared. Now I didn't add or subtract anything from the other side. I simply changed the form, right? It went from a trinomial, because it was a perfect trinomial squared, it went to a binomial squared. Okay, this is a perfect square trinomial going to a binomial square. Okay, that's all good. It's all fair game. All over 4a squared. What do I do now if I was completing the square? This is what we did really Friday and Thursday. We kind of worked on completing square. What should I do now to get the x by itself? Square root, both sides, right? So I'm taking the square root of this side, square root of this whole thing, okay? So I have x plus b over 2a equals what? Plus or what? Plus or minus square root of b squared minus 4ac. Now, a lot of kids are going to say, why don't you take the b out? I heard somebody say that. Somebody said b. Was it you, Memory? And she's not wrong if it was just a b squared. Right? If it was the square root of b squared, that would be true. But it's the square root of everything. So you have to do the subtraction and multiplication before I can take it out of the root. So that's a good point. I'm glad you made that. We don't want to take the b out yet. We have to square it and subtract 4ac from it before I can bring it out. Okay, I have to do all that math in there. So I can't bring it out right now. But it's over 2a. Now how come I brought that out of the root then? There wasn't 2 terms, there was only what? 1 term. So I can take the square root of 4, which is
2.
and I can take the square root of a squared, which is a, and that's okay. But the top part had 2 terms, so I can't bring it out. It has to stay under. Okay? Hey, now, what should I do to both sides to get the x by itself? Subtract b over what?
2.
Which, by the way, is the vertex, x coordinate. X equals negative b over what? 2a. Hey, is there a common denominator already here? Yeah, there's a common denominator already there. So I'm going to put negative b plus or minus the square root of b squared minus 4ac all over what?
2a.
2a. That's the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Here we go. I did this by factoring down here. And we're going to learn a little bit more about this in a second. But let's just do one for an example. Sorry, I erased from the 3x squared plus 12x minus 30. Let's say that factors, okay? And you can solve it by factoring. And we're going to learn when it's best to factor, when it's best to do whatever. That's really a true mathematician has all these tools in his toolbox, and he just decides which one to use. That's going to be the key to today's assignment, really, is deciding what to use. But just to show this as an example, let's just use the quadratic formula. Let's not even think about factoring out the 3. Let's not think about factoring after that. Let's just use the quadratic formula. Could I do it? Yes. You will need a calculator to do this if you're not going to factor, because the numbers get pretty what?
Big?
They're going to get big. How come? You're going to square the b. Now, in this case, we do happen to know 12 squared. What if that was 38? Would you know 38 squared? You don't know 38. It gets big pretty quick. Minus 4ac. 4 times 3 times 36. Do you know what that is off the top of your head? Most of you don't. I don't. So it's going to get big. Okay? Let's do this, though. Let's do it just like it says. So what should I write first if I'm using the quadratic formula? Negative b. So instead of b, though, what is b? 12. So I'm going to write negative 12. Notice this really doesn't mean negative always. It means the opposite of b. Are you with me on that? If this was negative 12, this would be what? Positive. But this is positive, so therefore this is what? Negative. So just realize it means opposite of b, really. So negative plus or minus square root of b squared. 12 squared is 144. I usually do that squaring when I write it down, otherwise it just makes it a mess. So I'm just going to do b squared, which is 144, minus 4ac. Now I usually write this out and then I'm going to do it on top because I don't ever have a calculator now. You guys might. Now here I know I have a negative times a negative is a what? Is there always going to be a 4 in that? Yes, that's part of the formula. So the 4 is always going to be there. The other numbers, the 3 and the negative 36, they're only there because of the a and the c. You with me? They'll change every problem. But 4 is always there. And it's always negative 4. But a negative times a negative will make a what? Positive. What's 12 times 36? Do that on your calculator. Somebody, 12 times 36.
432.
432? Okay. All over what?
2a.
2a, which is 12. Everybody agree with that? Oh wait,
6.
wrong. 6. My bad. Don't agree with that. Okay. So we take 144 plus 432. Right? Is that right? Okay. Do that on your calculator. What do you do? 144 plus 432.
576.
576. And then I need to take the square what of that?
Wait, where'd you get the 6?
Where did I get the 6?
Go back. It's
This 6.
2a.
2a. 2 times 3 gave me what? 6. That's a good question. I didn't write it down, so that's good. 2 times 3 is how I got the 6. That's a good question. Okay. Now what's the square root of 576? Anybody do that on your calculator? Do a square root of 576.
24.
24.
Here's 6.
Okay, that's 24. Now, by the way, this part right here is called the discriminant. We'll talk about that later, but I'm going to circle it here in the formula so that you can remember that. This is called the discriminant. And it's going to tell us the nature of the roots. We'll get to that in a minute, okay? But for now, just realize this discriminant was a perfect what? Square. What that tells you, if the discriminant is a perfect square, is that this would have factored. Okay? When you start out, you're just like, maybe you didn't see that 3 was a common factor, right? But if you just do it, it doesn't matter. If you have a perfect square, it would have factored anyway. You could have used factoring. Okay? But that's what that discriminant being a perfect square tells you. Oh no, don't go into that. Help us out. What? Oh, it's me. I got it. All right. Okay. Now what? Well, now I do the math. I do negative 12 plus 24 over 6, and negative 12 minus 24 over 6. These will not be exactly opposite. Okay, a lot of kids think that if they do the first one, they got the second one. That's not how it works. Okay? What's negative 12 plus 24?
12.
12 over 6 is
2.
2. What's negative 12 minus 24?
Negative 36.
Yeah, this is negative 36. A lot of kids want to put 2 and what?
Negative.
Negative 2. Wrong. Do the math. Okay? Do the math. This is negative, what did you say? Sorry, 36. Divided by 6 is,
Negative 6.
those are my what?
X-intercept.
X-intercepts, the zeros, the roots, the solutions. It was solved for x. Those are the solutions for x. You see what I mean? So that's why we call it that. And the quadratic formula gave us those two answers. Would it have factored to give us the same two answers? Yes. And I know it's factorable because it was a perfect square. Okay, now, good, you stop that.